Listen, zero trust is a complicated subject. That's why you suck at it. So, in this, the very first episode of the You Suck at Zero Trust mini series, we're going to be going over all the beautiful things that are zero trust. And we're going to do this by considering a greenfield deployment of a zero trust system. Now, I want to let you know right now, this video is not for education purposes. It's not to teach you a new cool skill so you can add something to your resume. It's not that at all. This is just an exercise in building something because that's what I like to do. I like to break it and make it. I got that name for a reason, right? So in this episode, we're going to be going over the basic requirements, the basic governance, and the basic architecture. Now I say basic, but it's not really basic, right? Please forgive me if you feel like I'm talking down to you. I am a professional and I am very qualified to do this. So you might catch me slacking in my tone, whatever. Don't get offended. First, let's recount the problem scenario. I do have a series of YouTube shorts on this, but I don't want to bore you to death with that playlist of shorts. If you want to check it out, cool, but we're just going to go over it right now, okay? You have a main enterprise, which is over you. You rub the sub enterprise. You work with outside enterprises that the main enterprise doesn't really trust. And also you got little brothers and sisters that are sub enterprises. Now there is a complicated connection of identity trust, of applications and databases. But if you really want the lowdown on that, check out the playlist. I'm not going to go over it again for those that have already watch the playlist. No, in fact, I just want you to focus on the sub-enterprise. Now, in this, you have 2 applications and 1 database. But we're getting ahead of ourselves, right? We don't want to go too much into the architecture, too much into the engineering or the applications. Let's first look at the requirements. Actually, you know what? Before we even do that, I just want to make it clear that I am using a lot of Department of Defense documents as references for reference architectures and for other solutions. And I'm also using the NIST 800 and 1800 series documents. If you want a complete list of all the links to those documents, I've included it in the GitHub repository that is housing this project. Check out the description for the GitHub repository link. And I also want to make it very clear that all these documents are completely unclassified and available for public use, so that way I don't have anybody saying I'm letting out government secrets or just in case a 3-letter agency wants to peruse the internet for hot words and keywords like DOD, zero trust, and all that fun stuff. But anyways, before I go down that rabbit hole, let's get back to the requirements. So I'm going to quote unquote cheat a little bit and take this figure of the enclave gateway model from NIST 800-207, the zero trust architecture. This is a OV1 architecture of essentially the model we're going to be using. Now, I use this for part of the requirements because it shows the overall pieces that are mandatory to create the zero trust architecture. On the top in the control plane, you have the policy engine, the policy administrator, and they're going to delegate the policy enforce points and the policy decision points of the zero trust architecture. And that's going to decide everything for this architecture, from identity management to the actual data flow, how data is accessed, all that fun stuff. And that actually happens on multiple levels. So the requirement is that we have the policy enforcement point and the policy decision point at multiple levels. Now, looking below, you'll see the data plane, and I'm going to talk about that a little bit more when we get to the architecture. Now, the next requirement is a trust algorithm. So trust algorithm is the full collection of rules that allow different service principals to access resources within a segment. Now, your sub-enterprise is a micro segment of the complete enterprise, so that's something to keep in mind. But your trust algorithm is going to be unique to your enterprise, and it will fit into the overall greater enterprise. So you have to remember that these users, the service principals, as well as other service counts and so on, they might not always be trusted. There's going to be different levels of users. So you'll have all the employees within your sub-organization, your sub-enterprise that can access your applications and database. But you're also going to have outside, less trusted employees, outside less trusted enterprises accessing your database and applications as well. So you have to think about the holistic picture, and that's what creates the trust algorithm. So we're not only talking the different attributes of the user, like where they are, but we're also thinking about what devices they're accessing from, the overall profile of this device, right? Has it been joined to your mobile device management program? Is it not? What applications are on it? That is all fitting into the trust algorithm. And going to the larger picture, the threat intelligence feeds and the auditing and monitoring is also a piece of it. And we'll talk about that when we get way deeper into the architecture of this project. That is not going to be in this video, because I am going to blow your little minds and see your brains melt out your ears. And I don't want that. I'm trying to keep this simple and bite-sized just for you, so you can understand what I'm doing and the steps I'm taking. So requirement 2 is that we need to create our trust algorithm using the holistic picture. You know what? That's too much. Let me take a step back. Smaller sentences. Requirement 2 is create the trust algorithm. Now we're going to move on to everybody's favorite subject, governance. Now this is typically reserved for the information systems security officer or manager, ISO or ISM, and these are typically the people that think they have power and like to say no, when in reality they're supposed to use the controls, the security controls, and apply them to there and give the mission owner, system owner, or authorizing official the best advice possible. This is what they're supposed to do. Reality and expectations are typically completely disassociated from each other. Anyways, I digress. So in this problem scenario, we're going to be using the risk management framework, and that is a product of NIST, the NIST 837 document risk management framework, which selects controls from NIST 800-53, all the security controls. Now, some people might say, oh, the NIST cybersecurity framework is better. Well, listen here. You're wrong and you're dumb. Okay, the CSF is for cybersecurity improving. If you're going to first build a system, you have to build a system and manage risk, because there is data in there that, if compromised, can lead to some serious stuff. And people need to understand that rather than be so overly focused on the new, cool, shiny product that's in cybersecurity. Okay. I'm sorry that you had to witness that. I didn't realize that I had all this pent up rage over people that suck at information security. People don't only suck at zero trust, they also suck at information security. But, let's talk about the RMF, because that is the governing framework that we're going to use for this problem scenario. And that's just a very common framework that I've used with all my work, because I am a professional. So the RMF broke up into 7 steps, right? You have your prepare step, where you're going to get the context of the system. You have the categorize step, to where you're going to identify the impact of what data compromise would be, what that risk is. Then you're going to select the controls from the NIST 853 family of controls. You're going to implement those controls, and we're going to talk about that in future videos, what's being implemented. Then we're going to assess the effectiveness of those controls and come up with plans of action and milestones. And from there, we will submit all of this to the main enterprise for them to approve this system and say, hey, you know what? You did it right. Keep on doing what you're doing. And then the final step is a bit of a continuous step where we monitor everything. And again, we'll save that for later. And then once you have gone through this framework of managing your risk, then you can begin to add new stuff in. You can begin to improve your system using frameworks like the NIST cybersecurity framework. Because who would have thought that you need to go through a framework that is required by most organizations, gone through the life cycle of this, get your system approved and operating before you can just add the new cool thing in because you have a friend in this company who wants a freaking sales commission by selling you a product, or are looking for a new job or future business, or you're looking for a job just because you're about to retire. Whatever the case may be, let's get this system approved using the RMF first before we start adding stuff in. This is why you suck at Zero Trust. At any rate, let's move on to the final piece. A piece I'm sure most of you nerds that suck at Zero Trust have been looking forward to, and that is architecture. Now, warning you, this is not a full-blown deep dive into the architecture. This is just a general overview. So again, we can get the requirements and what's going to be in the system for brevity's sake, for the project management sake. That way we don't scope creep this bad boy, and we can be really effective at our job and get it done quickly. So going back to the problem scenario, again, we have this main enterprise that is connecting to us and we're connecting to them. They are accessing our applications to visualize the data that our outside enterprises that we are working with have access to, and the outside enterprises have access to a very limited scope of their data. You know, this would be our OV1 architecture, this problem scenario. And by OV1, I mean operational view. It just provides a very high level scope of how things connect and how things interoperate. Just because I'm using all these reference architectures and other documents that provide requirements, we're going to look at the secure cloud computing architecture, which is a standard set forth by the big departments. So that way they can have these sub enterprises and sub components connect to their secure enterprise in a secure way, in a way that doesn't put them at risk. So the document we're going to take a look at is named the SCCA reference architecture, the cloud access point. And I'm going to go ahead and throw this image up right here. And this is a more in-depth look at the resources that will be within the sub enterprise, within our enterprise that we're going to be building. Now, if you look at this figure, you're going to see things like VDSS and VDMS. Now, these are core components of a secure cloud computing architecture for safe communication with the greater enterprise. And you'll see in the figure here, you'll see it says NIPRNet. That is an unclassified network, right? That all these outside people are connecting to. And even though it is unclassified, it still needs to be protected. So our application and database would fall essentially under a mission owner VPC. Now, I know that the sub enterprise is its own VPC, but we are going to kind of look at it as a complete package just for brevity, and we can build that whole secure architecture. Now, I highly advise you look at this document because it provides a lot of good insight for the technical requirements of what is a SCCA system. And these are the same requirements that cloud service providers like Microsoft and Amazon and Google have to meet in order to do business with the government. So that's something to keep in mind. If these big name players are doing it, well, I mean, it's going to be very secure. So this is the architecture we're going to reference. And with that, I'm really tired of hearing myself talk. I want to just get into the project, get into the next step. So we're going to go ahead and cut this video to the end. And I hope this was a good insight into why you suck at zero trust architecture. I hope you really had that realization, and I hope it made you want to read more. This is one of the primary reasons why you suck, is you need to read more. I know you're studying for the next cert. You're going to get after that new piece of technology. Well, you got to look at the bigger picture, okay? Read these kind of documents to get the bigger picture, to understand how zero trust is being executed by bigger players. Just to give you a little taste of what a finalized zero trust architecture would look like in the wild, this is a higher level view. This right here is what the DoD CIO and the NSA kind of envision for their system. It's like everything feeds into one giant security information system that is analyzed through AI and ML and all that fun stuff. And this is actually in the DoD CIO Zero Trust Architecture Reference Architecture, another great read that I advise for you. So that's it. This is the end of the video. Again, I am doing everything in a GitHub repo. I'm going to leave the repo in the description of this video. You won't find anything too exciting as of this video, just because I'm building up, right? I'm building it all up. But eventually I'm going to put in the Terraform code that's going to put everything together as far as the infrastructure goes in there. So it'll be a great repo for you to follow. With that, if you like what you see, if you want to realize more why you suck at zero trust, well, go ahead, like, subscribe, comment, tell me why I suck, because I will very quickly crush your soul as to why I am very much better than you at this subject. But, you know, let me not get a little too aggro. Excuse me. I'm sorry. And if you want to get involved in this project with me, well, leave a comment. Let me know, because I'm thinking of different ways to involve you all, because I find it's very cool to get experience on this kind of technology, whether it's DevOps, Terraform as infrastructure as code, zero trust, or building secure systems. I find it very cool to get experience on these things for you to put on your own resume, in your own GitHub, or just generally talk about, because I think this shit is really cool. So let me know and stay tuned for the next video.